that 2 will go up. That 2 will cancel with the 4, leaving a 2 outside. So that will be pi over 2. And I can also take that 3 outside. Is that right? And the 2 and the 3 will multiply to give me pi over 6. Did you understand that? 3 divided by 2. The 2 goes up. And the 3 multiplies by 4. That will be 2 over 12. Or that will be pi over 6. That will be pi over 6 u to the power of 3 over 2 from u equal to 5 to 17. What we need to now do is replace u by 17 minus replace u by 5. That will be pi over 6, 17 to the power of 3 over 2 minus 5 to the power of 3 over 2. There's no way we can simplify this. The only thing we can do is put that in the calculator and get an approximate value. So that approximately is 30.85 square unit. So when this arc is revolved about the x-axis, the surface generated has an area of 30.85 square unit. Can you visualize what that area will look like? Alright. You can also do this on the calculator, just like I showed you. Finite integral. And follow the keystrokes I just showed you, and it gives you 30.85. Alright, let's do another one. Find the approximate surface area, which obviously suggests that you will not be able to integrate it, to simplify it fully to get the exact value. You got to find the approximate value. That means use your calculator to evaluate the integral of the surface generated when the graph of y equal to ln x is revolved about the x-axis. Do you remember how the graph of y equal to ln x looked like? Like that. And if you revolve it about the y-axis, it's going to be like that. A graph like this, revolved about the y-axis, you produce a beautiful flower vase-like structure. Alright, that's our equation. Carry that with you. So our function is y equal to ln x. Well, we start by finding the derivative of that. What is the derivative of ln x? If f of x equal to ln x, what is f prime x? Is 1 over x. Our next task is to find the square of that. So f prime x, the quantity squared, is 1 over x squared. Well, we found f prime x squared. We need to add 1 to that. 1 plus f prime x squared is 1 plus 1 over x squared. Let's simplify this. That will be x squared plus 1 over x squared. What is the next step? We need to find the square root of this quantity. Is that right? This quantity needs to be under square root. So find the square root of 1 plus f prime x squared is square root of x squared plus 1 over x. Well, you can again split this into 2 square root. That will be square root x squared plus 1 on the numerator, and square root x squared is x on the denominator. So that will be 1 over x square root x squared plus 1. That is this quantity. And what is r of x? Now this is the graph of y equal to ln x. And you're going to revolve it about the y-axis. Now look at the surfaces that are generated. This is the radius. Now what is that radius? The radius is the distance measured from the axis to any point on the graph, and that distance is called x. So r of x equal to x. That's right. So this r of x is actually x. R of x equal to x. Now therefore we have now the complete formula for the area. A equal to 2 pi integral a to b. We know the values of a and b. R of x equal to x, and the square root quantity equal to this. Replace all that. It will be 2 pi integral 1 to e x times 1 over x square root x squared plus 1 dx. And that will be 2 pi integral 1 to e square root x squared plus 1 dx. Well, we haven't actually developed a method to integrate this yet, but soon we will know how to integrate quantities like this. So until then, we are going to find the value of this on the calculator. So go like this: 2 pi times finite integral square root x squared plus 1 when x goes from 1 to e. Alright, follow these keystrokes, and that will give you 22.9 is the approximate area of that surface generated. I hope you can visualize how this surface look like when this curve is revolved about the y-axis.